let's talk to the index addressing mode. In index addressing mode, effective address will be calculated based on the index register addresses. So what will happen? Effective address will be the value given in the index address plus the address given in instruction. So what is the use and why we are using SI plus address in instruction? So for example, index addressing is very useful in the array. When you are iterating in array in a loop, it will be very useful. So what is happening if there is an array? For example, there is an array and there is a multiple is there. So how we can access the array? We can access the array with index. For example, 0, 1, this will be accessed by 0, 3. So here what will happen if this array will go into one memory block? For example, from here to here it will be this array, but once it is swap out and swap in, it means it's relocated, then the new memory block assigned to this array is here. But still in our code, what will be happen? We can access this with the index only, that is I as an integer. So 1, 2, 3, 4, but this location is completely changed. So what we can do, we can use the index register. For example, SI, initially its value will be, for example, 100, and so if it's initially the value of SI will be 100, then how we can access the array is, first one is, so how we will access the array? The first element of this array will be at 100. Second element of this array will be 104. Why 104? Because 4 is size of element. For example, it's in array of integer, and integer acquire 4 bits. So the next address will be 104, then the next address will be 108, like that it will be there. Now if it's relocated to the new memory block, and here it is a 500, so what will be the next address? Next address will be 500, 504, 508. So we can easily access this if we can change the SI equal to 500. So what we need to do? We need to just change the SI register. So if you change the value of index register, then we can easily iterate the array. We will find the right addresses. So this is the use of index addressing mode. So you can see here example, it is saying move AX comma SI plus 05. So what will happen? This SI will be the with the root address of this array, and then it is saying just add to the 05. So if the SI value is 100, then the address will become 105. If the next time, if this array is relocated, swap out and swap in, and now it is getting the new block of memory, and here S1 will be 1000, then the effective address will be 1005. So this is the use of index addressing mode. So we can, because in program we cannot change here 100 to 500. Here in program we are using I only, that will the index, that will the first, second, third, and fourth. But automatically it will be adjusted using the SI register value, that is the index register value. So I hope it is clear. Okay, let's talk to the next one, that is auto index incremental mode. What is happening here? In the previous one, we see that the effective address is sum of the index register value plus displacement. But here we are not using the index register. We will use the register value that is given in the instructions. So the effective address is the register specified in the instructions. And the important thing, after accessing the operand, after processing these instructions, the content of this register are automatically incremented to the next consecutive address. So here next consecutive address is not always fixed. It depends upon what type of elements is there in the array. So for example, let's take an example. Consider one array here, and it having multiple like many elements are there in this array. So here you see we are using R2 plus. It means that R2 is the register. So second register, we have to take the value from this register, that is the address, or you can say that is the base address of the array, and plus is there. It means that auto incremental mode. So once we will process these instructions, or we will fetch the operand from these instructions, it will automatically increment it to the next consecutive address. How it will be happen? So in this array, let's take an example that the base address is at 100. Okay, and each element, size of the element is very important. So size of the element equal to 4 bit. So what will happen? So next consecutive address will be not 101, but it will be 104. Similarly, next consecutive address will be 108. So 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 first it will read from R2, and the next instructions it will increment the R2 value by this D. D is the size of element. So this is what we are doing here. You see this add R2, R1 comma R2 plus. So plus sign is there, it means the auto increment mode is there. And if you convert this instruction, so what it will do, first it will make this instruction, what is this is like there, you know that instruction is always flowing from this way. So this is the source and this is the destination. So we have to add the value of R1 and the R2 and assign into the R1. So R1 equal to R1 plus MR2. So this is the destination, and this is the source. So we are going to assign R1 plus R2 into the R1. And after that, what we are doing, we are going to add R2 with the 4. So 4 will be the size of the element, that is called the displacement, whatever you can say. Now you see here, this instruction, it is written like R1 equal to R1 plus MR2. What does it mean? It means that we are not going to add simply the value of R2. We are going to get the address from R2, and then we will go into the memory of this address, and then they will find the data here. So R2 contains effective address. I hope it is clear. So So auto increment mode, and that's why you see here I told you that either we can use this of this bracket or at the rate if we are using the effective address, not the data in the register. That is the indirect register mode, indirect register addressing mode. So here you see this bracket is there. It means that we are going to use the value of this R2 is the effective address. It's not the value, it's not the data directly. It is the value of the memory, that is the effective address. So what we have to do, CPU has to go to the memory and then at that index, at that memory place, whatever the data is there, they have to perform the operation on that data. So this is the auto index. One important thing, first they will process the instructions and after that it will increment to the next consecutive address. R1 plus means it will not always plus 1, it will be plus D. D is the size of the element. This will be used in uh, stepping through the array, like looping into the array. This is useful, this addressing mode. Let's talk to the auto index decremental mode. Just now we covered the incremental mode. Now we are going to look into the decremental mode. What is happening in this case? Effective address is the content of a specified register in the instructions. So we have to read the address. Remember that this is again a address, effective address. It's not the value. It's not the directly data. So we are going to read the value from R2, that will be the effective address, and then again we will go to the memory and then we will find the data. So that is a simple register indirect mode. Now what is the decremental mode? In the decremental mode, once the before accessing the operand, the content of this register are automatically decremented to the point to the previous consecutive addresses, previous consecutive memory. So it will be, because you see that here written that R1 comma minus R2. So here minus is before. So if it's before, then they will process before getting the result. Okay. So how we can break it down? So first we have to R2 equal to R2 minus D. What is the D? D is size of the element. And once we know the R2, so first we will reassign the value of R2 and then we will assign the R1 equal to R1 plus M of R2, memory of R2. That is memory of R2 means we read the R2 and then we will go to the memory and then we will find the data. Okay, this is very useful in the stack operations, in array, sorry, in a stack and in array. So I will tell you. So for example, this is array. Now, for example, R2 is here at this location. So what we have to do, they have to decrement by 4. I'm just giving an example. For example, here it's 160. Sorry, 160. So what will happen? The first address will be 160 minus 4. That will be 156. So 156 will be the address here. Then this is the first element in the sense last element in the array. Now the next element will be 156 minus 4, so it will be 152. You see here, because 156 to 160, that is the last element. So that's why first we are reducing 4. We will go to the initial address of this block and then we will get the value. Similarly here, first we have to go, now right now it's 156, we have to go first 4 minus and then we will get it 152, and then we will get the data from here. So this is the auto decrement mode. It is very useful in stack operations for push and pop, similarly for array. I hope it is clear. If you have any confusions, please put into the comment. I will be really happy to help you and clear your doubts. Thank you.